Hello, today we're going to continue our study of topic 3.10, part 2, trigonometric equations and inequalities, focusing more on the inequality side of things today. This is really not a new topic. We learned and addressed and reviewed inequalities in Unit 1 when we studied polynomial inequalities and rational function inequalities. And so similarly, we're going to solve inequalities involving trigonometric functions in this unit. So applying things that we previously learned in Algebra 2, Algebra 1, reviewed at the beginning of this year, and we're going to go one more time using our trig functions. So let's look at example 1. The graph of f is defined for all values from negative 2 pi less than or equal to x less than or equal to 2 pi. So that's how they're defined. In other words, when you look at this graph, it's going from negative 2 pi to 2 pi and is including the endpoints on this graph. What are all values of x for which this is true? So what does that mean? F of x less than or equal to 0. That means the function values or the y values are less than or equal to 0. So if I'm looking at this graph, where would I find the y values that are less than or equal to 0? I would find them below because the y values that are negative are down here. So I'm talking about the ones that are below from here to here, and the ones that are below from here to here. And remember, it did say or equal to, so I'm also including the point here, and here, and here, and here, because of this notation right there, okay? So then if we're going to write an inequality for that, then f of x is less than or equal to 0 when what is true? When x equals, and we have this one value down here, don't forget about this guy. It's not part of either of the intervals, but it is equal to at that point. So I would say that x equals negative 2 pi. I would also say that we can go between negative pi less than or equal to x less than or equal to 0, because remember again, the symbol right here says equal to. Or the last part of my interval could be pi less than or equal to x less than or equal to 2 pi. Now, do be careful on multiple choice questions. It is possible that these could be intervals, but you would have to be very careful here because this is not an interval. So interval notation wouldn't work here. It would, but it's kind of awkward. It would be like negative 2 pi to 2 pi, hard brackets on both sides. Or it could be written out in inequality. So I think you need to be prepared for either. And that shouldn't be comfortable. We've spent a lot of time with both methods so far this year and in previous math classes, so that should be hopefully straightforward. Okay, so solving inequalities, it's easy. When we have a graph, right? When we could just look at that graph and pick it up and see, physically where we were talking about. So it's pretty easy when you're given a graph. But unfortunately, that's not all of them. So we need to understand how to solve inequalities analytically as well. And sometimes we can do it very easily analytically when it's a simpler inequality. And that only involves like one trig expression. And so then it's just a matter of understanding your unit circle values. For example, example 2 says, what are all values from 0 to 2 pi? Notice this time we can include 0, but what can we not include? 2 pi is not included this time for this expression right here. So when the sine function is greater than or equal to root 2 over 2. So remember that sine is the vertical displacement from the horizontal axis. So we're looking for all possible angles, their measure, where the y coordinate is at least root 2 over 2. So that's an important word there, at least root 2 over 2. So in the figure, we're going to look at this unit circle here, and we're going to figure out where that's going to be true. So if you think about root 2 over 2, you can see the first root 2 over 2, and we're wanting all the sine values greater than or equal to root 2 over 2. So that's putting us starting right here at pi over 4. And if we look at those values, they go and get bigger and bigger closer they get to this, and then they get bigger until we get over here to 3 pi over 4. So those are all going to be the sine values. So remember the sine values, that vertical displacement. So we're looking at the y. So we can see we have y here, looking at these y's as we go around. And so we can easily write an inequality by just thinking about what that might look like on the unit circle by saying pi over 4 less than or equal to x less than, and it says equal to right here, so we can include the other end, 3 pi over 4. So that's just looking at those values on the unit circle. So that's what I mean by a simple inequality, because we're just taking one thing, either sine or cosine or tangent, not an equation where we might have multiple trig functions in there that we have to solve for. Before we move on, I'm going to come back up to example 1 real quick, and I'm just going to go ahead and write it in interval notation just so that you would have an example in your notes if you do end up needing to do that. So if we were going to represent this in interval notation, we would say negative 2 pi to negative 2 pi, hard bracket, skip over, and then we are including this, so hard bracket negative pi to 0, and we are including 0, and then we're skipping over to pi and going from pi to 2 pi, and once again including. So it might look something like that. Oftentimes, though, when you're working inequalities, your answers will tend to be in inequalities, but I just thought we might jump back before we go to the next example and just have one in there. So we have one on inequality notation and one with interval notation. All right, let's move on to example 3. So in example 3, notice it's not just a simple trig function now. We actually have an equation. So the equation is f of x equals 4 plus 2 cosine x. And then we have another function called g of x, which happens to be 3. And it wants to know for what are all values of x in the xy plane such that 0 is less than x is less than or equal to 2 pi. So notice both of these are equal to, so I'm going to include 0 and the 2 pi possibly, for which f of x is greater than 0. So that means this function is bigger than this function. All right, so what this is telling me to do is that I'm going to be comparing the values. So the first thing I need to do is figure out what trig function am I actually comparing. So when we say x equals, we're setting, sometimes that means we're solving, but in this case, it's telling us to set f of x and g of x together so that we can solve. So f of x is this function right here. So I'm going to say 4 plus 2 cosine x. And then it says is less than g of x, and g of x is 3. So this little set of symbols is telling us what to do. So again, another case of being really mindful of your notation. All right, so we want to isolate our cosine function. So I'm going to move the 4 over. So that's 2 cosine x is less than, subtract 4, so that's minus 1. And then cosine x is less than, going to divide by positive 2, so that's negative 1/2. Remember, if you multiply or divide by a negative number, it does switch the direction of your inequality. So being able to isolate it, so I had to do a few steps, but I can still isolate it. Once I get it to this point, I can basically think about what's happening on the unit circle to help me answer that question. So I want to know when the cosine of x is less than negative 1/2. All right, so when I'm looking at my problem here, I'm looking at what's the behavior on this unit circle that's going to be able to let me identify what's happening here when cosine of x is less than negative 1/2. So the first thing I'm going to do is identify where my negative cosine negative 1/2 is. So I can see, and I know that in this quadrant, cosine is the first term, and I can see I have a negative 1/2 there, starting at 2 pi over 3. And as I'm looking at the cosine values around here, I can see that the next cosine value happens to be down here at 4 pi over 3. So that means we're talking about from 2 pi around to 4 pi over 3. So when I write my inequality, then it should reflect that. So it's going to be starting at 2 pi over 3. Is it going to include the x? No, because we want to know when this is greater than this, not equal to. So then we're going to say less than x, and then all the way around to 4 pi over 3. So that's going to be 4 pi over 3. Again, you could do an interval notation where this is soft bracket 2 pi over 3 to 4 pi over 3 because we are starting here and working our way around here, so it's in order. So we could do that inequality and make it look something like 2 pi over 3 over 4 pi over 3. Sometimes when you're solving, you have to be careful about that because, if you're going from here to here, but then might be going in a different direction for a different factor. So you do need to be careful. And again, the notation we were being mindful of was this. And then making sure we understand our restrictions so we know what we can include and what we can't. All right, moving on to question 4. Another one where we're going to use the unit circle to answer the question. So go ahead and read it. First read, second read, and see what you can do with this one now that we've had a couple under our belt here. So go ahead and pause your video. Okay, so hopefully you got it isolated and you got cosine of x is greater than root 3 over 2. So remember, cosine is the first entry. So if I look at the cosine values around here, they're all negative, so that's not going to help me. I find a cosine value on this part here and on this part here. And so when I'm looking at where those occur, I can see at 11 pi over 6, cosine is root 3 over 2 all the way up, and then I can see a root 3 over here. So I'm looking at this piece of the graph. I can't really give this as a single inequality, however, because I have that 0 right there in the middle. So I can't just say it goes from 11 pi over 6 to pi over 6 or pi over 6 to 11 pi over 6. If I say pi over 6 to 11 pi over 6, I'm talking about all of this. And if I say from 11 pi over 6 up, then I'm also saying, I'm also including that 0 and possibly the 2 pi. So this one is a little different in how we're going to write the solution, but we're going to break it up and we're going to go from 0 to pi over 6, and then we're going to go from 11 pi over 6 to 2 pi, right? Because remember, it's including both 0 and 2 pi. So we do have to represent both of those values. So the easiest way would be if I do 0 less than or equal to x less than pi over 6 and or 11 pi over 6 less than x less than or equal to 2 pi. So I could write it that way. And I think probably for me, that's the easiest one right there. But you could say from 0 to pi over 6 union and then skip all the way around the circle to 11 pi over 6 and go to 2 pi. So if we did that, then it would look like something like include the 0, go to 2 pi over 6, don't include the 2 pi over 6, jump around the circle to 11 pi over 6, which we wouldn't include, and end up at 2 pi, which we would include. So you could be looking at it in inequality or interval. And like I said, a lot of times when we're doing inequality work, then our answers tend to be in inequality form, but on a multiple choice, it could go either way. So just as you're thinking through, I'm perfectly happy with you giving me this answer right now, but in your mind, you need to think through about what would it look like if it happened to be a multiple choice question and they gave it to me in interval notation. Interval notation, we have to pay really close attention to the endpoints because this means included, this one does not. But when we do inequalities, we have to pay attention to the symbols because it could be included and it could not. So it's just kind of a few of those things to pay attention to when you're working with problems like this, where you can simply isolate one of the one of the tangent functions and be able to interpret that from the unit circle. So now we're going to do a little work with with inequalities in a little bit different form. And so let's kind of review some things. As we did in Unit 1, we can also solve inequalities with trigonometric functions. So we have used sign charts in the past, and we learned how to use those in Algebra 2 as well. But we can use those to solve inequalities involving trigonometric functions as well. So this is kind of a series of steps or a guideline you can think of as you're working through inequalities, if it helps you. So to solve an inequality, we're either looking for when f of x is less than 0 or f of x is greater than 0. And what that means is when the function value or the y value is less than 0, or when the function value or the y values are greater than 0. So that's another one of those mathematical notations that tells you what you're supposed to be doing when you're working the problem. So in this case, step 1 would be to find where it is equal to 0, because that's going to be our dividing lines on our sign chart, if you remember from earlier in the year. And so to do that, we solve for x. So we may need to factor in some steps. We may need to do different solving techniques. The one thing we really don't want to do is to divide out a trig function, like divide both sides by tan, because what happens is you can lose solutions that you can't mathematically get back. So then after we've set it equal to 0 and solve for x to find those places on the number line that are going to break our number line up, then we're going to create a sign chart with the solutions marked from step 1. So be sure that you include or think about any domain restrictions that might happen. Like if you're talking about a square root, then you can't pick a number like -7 to go under the square root sign. That function naturally does not include any of those. So you have to think about implied as well as actual specifically stated. Then you're going to test one value in each interval. And then once you do that, then you're going to look at your results. The results will either be a plus or a minus. We don't necessarily need to crunch the numbers. Sometimes we have to because they're too close to tell. But usually we're able to easily plug them into the factored form and be able to tell that. And then we're going to look at the values to see which ones satisfy or what the values produce when we plug it in. And then we're going to be looking at the intervals. So we interpret the sign chart, the answer. So for today, we're going to talk a little bit about how we do the sign chart in our head, but we're also, to speed things along just a bit, we are going to go ahead and punch stuff into Desmos and look at picture of the number line. So if you want to have your Desmos open so that you can type it in yourself in practice, you can. I did go ahead and grab the graphs for 5 and 6. So I have them printed out so we can look at them and understand what's going on just a little bit better. So if you're someone that likes kind of to go through steps to figure out what needs to be happening, you have some steps here that you can refer back to. All right. So let's go through example 5 first. What are all the values of theta between 0 and 2 pi? Notice this time we're including both 0 and 2 pi, for which sine squared x plus sine x is less than 0. So to start a process like this, to set my problem equal to 0, I'm going to write this down here. So I have sine squared theta plus sine theta is less than 0. So everything is on the same side. It's set to 0 so that I know I can factor. So I'm looking for a GCF. Is there a GCF I can take out? Sure, because sine squared theta is just sine theta times sine theta. And here's one sine theta. So if I think about this as having two sine thetas and this as having one sine theta, the greatest common factor that I can take out of both pieces is sine theta. And that's going to leave me with sine theta plus 1 less than 0. All right, so once I have my factors, then I'm going to take each factor separately and I'm going to address that factor. So I'm going to find each factor, set them to 0. So for instance, here's the first one, here's the second one. So I'm going to do sine of theta equals 0. And then I'm going to do a really quick sketch, just like we've been practicing on all our problems. When is sine of theta equal to 0? Well, it's equal to 0 at 0. It's equal to 0 at pi. And then once again, when we get back to 2 pi, because remember, it did say this time we could include 2 pi as well as 0. So from this factor, I have three things that are going to go on my number line: 0, pi, and then 2 pi. Now we're going to take the second factor, and we're going to say sine of theta plus 1 equals 0. Move the 1 over, so we have sine of theta equals -1. There is only one place on the unit circle where sine is going to be -1. This is sine, right? So that's going to happen down here at 3 pi over 2. And remember, we said in the last lesson, you're going to have a factor, you're going to have a sketch labeling and showing me where those 2 or 3, in this case, angles are that we're talking about. All right, so once that we've done that, then we're going to set up a number line, and it's going to have all of these factors on it. So we know that we're going from 0 to 2 pi. So 0 is the end, 2 pi is this end. And we know that we're looking at pi, 3 pi over 2, 2 pi, 0. So 0, and then we're going to have pi, and then we're going to have 3 pi over 2, and then we're going to have 2 pi. All right. So 1, 2, 3, 4 things. So those 4 things split our number line into 3 pieces: one from 0 to pi, one from pi to 3 pi over 2, and one from 3 pi over 2 to 2 pi. So now we would typically be looking at ways to check. So I'm going to go ahead and calculate a couple by hand, just so you'll see it is definitely doable. And then I want you to go ahead and put it in Desmos, and we'll look at what that graph looks like to help us figure out our plus and minuses. But some of the things to keep in mind when you're testing values with trig, I try to test the axes when I can, because those are going to be the easiest numbers to work with them all being zeros and forms of 1. If that doesn't work, then I try to see, is there a pi over 4 angle in that window that I could use? If I have to crunch numbers with the others, then I will. But those are my 2 go-tos to make my calculations easier and just make it a little easier to calculate. So what I mean by that is if I go from 0 to pi, then I could use pi over 2. Because remember, it would start here at 0, we'd end over here at pi. 3 pi over 2 is in the way, in the middle. So then I would say, looking at my factored form is usually the easiest. So I would say sine of pi over 4. And then I'm multiplying that by sine of pi over 4 plus 1. And so then what I'm trying to figure out is this going to be positive or negative? Is this going to be positive or negative? Because then I'm going to multiply them together to get the overall space here. So theta, and here is going to be pi over 4. All right, so what do we know about pi over 4? We know that's square root of 2 over 2. So we know that's positive. And then we know this is square root of 2 over 2, which is positive, plus a positive number means its factor is positive, and a positive times a positive then is just going to be positive. All right, so let's go to the next interval, and I would be looking from pi to 3 pi over 2. So if I'm trying to figure out what's a pi over 4 between pi and 3 pi over 2, then I would do 5 pi over 4. So let's see, I'm going to erase this so we have some room. So then I'm going to say sine of 5 pi over 4. And then I'm going to do sine of 5 pi over 4 plus 1. So if I know my sine values, remember those are the second coordinates and everything is negative in this quadrant. So then this value here is negative square root of 2 over 2. So that gives me a negative. And then over here, that would be negative square root of 2 plus 1. So square root of 2, remember, falls between 1 and 4, the square root of 1 and the square root of 4. So that's going to be a little bit bigger than 1. And then if I take a fourth of that, that is going to be a number less than 1. So that makes this a smaller negative than this. So that means on this side, I'm going to have a plus. And anytime I multiply a negative times a positive, then that means every y value in this interval will also be a negative. All right, so let's go on to the next one. And so now I'm looking for a nice number between 3 pi over 2 and 2 pi. And so my pi over 4 number that I would use here is I would do 7 pi over 4. So I'm going to say sine of 7 pi over 4. And then I have sine of 7 pi over 4 plus 1. So I know in the fourth quadrant, sine is going to be negative. So once again, I have a negative square root of 2 over 2. So that's going to be negative. And then here I'm going to have a negative square root of 2 over 2 plus 1, which is going to be a little bit less than 1. So then that part of it is positive, which makes all function values in this interval from 3 pi over 2 2 pi have the same y value, which a negative times a positive is a negative. All right, so as you're looking at this, remember what we were trying to find. We wanted to know when the function itself is less than 0. So if we look at the pieces here, it is less than 0, meaning it's negative, and it's going to be negative from here to here. Okay? So keep in mind, it did not say equal to, so I can't actually use the 3 pi over 2, but I can write my answer to reflect the other part of that. So for this problem, I could say that I want to do, let's start over here, pi less than, because it can't be equal to, x less than 3 pi over 2. Or then I can go 3 pi over 2 less than x less than 2 pi. So if I write it in inequalities, that's what it's going to look like. If I write it in interval notation, remember you can't include anything. So I would say soft bracket pi to 3 pi over 2 union 3 pi over 2 to 2 pi. Okay, so you get an idea now how to use your trig step to be able to determine. Notice that this was easy because it was by itself. This one I just had to do a little thinking. And it's okay to put your plus and minuses above it, but just make sure you're identifying. Like if you just leave this plus plus, that doesn't tell me that you know for certain that that is positive. So if you're using these little markers to help you reason through the problem, make sure that you have a definite sign on each interval. Because I'm not going to be able to try and guess what you're thinking. I need to see it. So I need you to be purposeful when you're writing those out. Now, I told you we were going to look at some of this on the number line, so you can, or on the graph, so you can see. So here is my Desmos for this activity. So as you can see, we are at 0 here. We are at 0 here. We are at 0 here. And we're at 0 here. And so these were the numbers on my number line, 0, pi, 3 pi over 2, and 2 pi. So those were my quadrantal angles. And then remember our number line, it said from 0 to pi, it was positive. So look at all the function values. They're all positive from 0 to pi. And that's what we demonstrated on the number line. Then from this 0 to the next, from pi to 3 pi over 2, it's all physically below the x-axis, which makes this whole area negative, and that's what's reflected on the overall sign for that piece of my number line. And then the last one goes from 3 pi over 2 to 2 pi. So 3 pi over 2 to 2 pi. And so we can see that that is all below and negative, which is what it has in this interval too. So you can kind of confirm your number lines in Desmos. That's why we suggested that you use it today. Not that you shouldn't be able to do basic calculations, because what if you're on the non-calculator portion of the test? But I just wanted you to see that we can definitely do it. We are brilliant and we can figure out those pi over 4s if we can. But we can definitely use Desmos as well. Okay, so let's go on to our last example. So in our last example, remember the things we're paying attention to are what is the interval that I'm using, and then what is my equation and how is that inequality set up. So the first thing we have to do is we have to get that cosine to a point where I can have factors, or I can condense it down to a single cosine value. And we obviously can't do that here because one is squared and one is not. And hopefully you should recognize that this is just a factoring problem. So we have 2 cosine squared theta plus cosine theta minus 1. And we want to know when are all of those values greater than or equal to 0. So if you're struggling on how to factor, the coefficient here is 2, the factor back here is -1, multiply them together, combinations of that has to give you your middle. You could think about this in terms of this being 2x squared plus x minus 1 if you need to need a little help that way. But hopefully you can see that if this is 2 cosine squared theta, then one of them is going to be a 2 cosine and one of them is just going to be a cosine, because when you multiply those two factors together, it has to be 2 cosine squared theta. So when I factor this, I get 2 cosine theta minus 1 and cosine theta plus 1. So you do have to be able to factor with something other than x's and y's. It's okay while you're thinking through this here in the beginning to think that I have 2x squared plus x plus 1. But that is only to think about it that way, not to solve it that way. Do not go in and say cosine of x equals x and da-da-da-da-da and do all of that. I don't want to see that. I want it factored properly with your trig functions. You should be able to do that by now. Okay, but I have no problem with some thinking math. If you're trying to think and reason your way through a problem because you're really stumped, this is cool. But if I see in your work x's instead of cosines, then that's not what you're solving, right? You're just willy-nilly using something else. So be really careful with that. So luckily when I do this, I have 2 factors. So I can take one factor, 2 cosine theta minus 1 equals 0. So I'm going to move the 1 over. So I have cosine theta. So I'm going to move the 1 over and then divide by 2. So cosine of theta is 1/2. And you can definitely do those multiple steps in your head, but be sure you take the time to set up the factor equal to 0, because that's what allows you to be able to do this mathematically. All right, so now we're going to our unit circle and thinking what has a cosine value of 1/2. And so that's going to happen here at pi over 3, and it's going to happen here at 5 pi over 3. So once we have those factors, we can move to the second one. So here's my second factor. So I have cosine theta plus 1 equals 0. Cosine theta equals -1. So when I look at my axis, there's only one place that can happen on the quadrantal angle over here at pi. So we now know we've set it equal to 0 and solved. So we now know what can go on the number line, right? So we know that we're going from 0 to 2 pi. So the ends are going to be 0 and 2 pi. And then on that interval in between, we have 3 values. We have pi over 3, then pi, then 5 pi over 3. So we have a pi over 3, we have a pi, we have a 5 pi over 3, and we have 2 pi. And we know that all of these, the 0 is an end value here that we know we actually are on the x-axis at pi, we're on the x-axis at pi over 3, and we're on the x-axis at 5 pi over 3. But we have to be careful and make sure we know what our inequality is telling us. It's telling us that we can include those points as we're working through this. Okay, so we have our number line set up with all of the values that we found here. We're going to test values and practice that together, and then we'll look at the Desmos to make sure you were good there. So if we're going from 0 to pi over 3, then I'm going to test theta equals pi over 4. So what that means is, remember, you're testing it in the 2 factors. So you're going to say 2 cosine pi over 4 minus 1 and cosine of pi over 4 plus 1. So when I look at cosine of pi over 4, that's root 2 over 2. When I have root 2 over 2 times 2, that's going to make it even bigger. So then a bigger number minus the 1 is going to make this positive. And then we look at the factor over here. We know that this is root 2 over 2, and that's positive, plus another positive makes that positive. So then you're going to determine the overall sign by saying positive times a positive is a positive. I do expect to see the overall sign. If you're doing this so close to the number line that I can't tell, then I can't give you credit for that. So either make it go above, make it go below if you're needing to write it down. If you can do it in your head, that's okay too, as long as you're testing values. All right, so now let's move around the graph and we're going to go from pi over 3, which is going to be over here, all the way to pi, which is over here. So then a number that I might work with that goes from pi over 3 to pi might be pi over 2. So I think I'm going to do theta equals pi over 2. Anytime you can use a quadrantal angle, I would highly recommend it. If you're having to do it by hand, then it's going to make the math much easier. So we're going to have 2 cosine pi over 2 minus 1 and cosine of pi over 2 plus 1. So if I have cosine of pi over 2, that's 0. 0 times the number is 0. 0 minus 1 is going to give me a negative number. Then I'm going to test it over here. So I know that cosine of pi over 2 is 0. 0 plus 1 is going to give me a positive number. That means the sign on this overall interval is negative. All right, so if I'm going from pi around, so pi is the halfway over, and I'm going around this way to 5 pi over 3, which is in the fourth quadrant, then I'm going to use 3 pi over 2. So I'm going to say 2 cosine 3 pi over 2 minus 1 and cosine of 3 pi over 2 plus 1. So as I'm thinking through, so I have cosine of 3 pi over 2 is there on the quadrantal axis, and cosine is the stay put number, doesn't drop down or up. So then that's going to make this 0 times 2, which would give me 0, minus 1, which is going to give me a negative number. And then over here, I'm going to have cosine of 3 pi over 2, which we know is 0, and 0 plus 1 is going to give me a positive number. So the overall sign of this part of my plus minus number line is a negative. And again, you've got to tell me the overall sign of each one, and it's not, that shouldn't be all mucked up and junked up together that I can't tell. So if you need to move these up and out of the way, fine. If you want to do it in your head, fine. But I need to see this, and this clearly stated on your plus minus number line. Okay? So now we're going from 5 pi over 3, which is in the fourth quadrant, up to 2 pi. So I'm going to use, how about 7 pi over 4? So when I test that, I'm going to get theta equals 7 pi over 4. And what did we test here? We tested 3 pi over 2. All right. So now I'm looking at that piece of the number line. So I'm doing 2 cosine 7 pi over 4 minus 1 and cosine 7 pi over 4 plus 1. And so when I look at 7 pi over 4 in the fourth quadrant, cosine of that is going to be positive. So 2 times a positive root 2 over 2 is going to be bigger. And so then I'm going to get a positive. And then here I'm going to get root 2 over 2, just positive plus another positive gives me a positive. And so that means the overall part of the number line has function values that are positive. So if we are determining our inequality, we want to know when those function values are greater than or equal to 0. And so that's going to be the plus areas of my number line. So that's here and here. And so that's how I would write my solution for this based on testing the numbers. So it's not, or it is included, is a big question to ask yourself before you write the answers. And in this case, it is. So it can be on the number line or positive. So on the number line, my values were here, here, and here. And positive is this part, not including 0. And positive is this part, including 5 pi over 3, but not 2 pi. So we have these values that are on the number line, which means they are equal to 0. We have a positive area here and a positive area here. So we're going to go from 0, not including 0, to pi over 3 and including it because it's on the number line. Then we have this point in the middle we can't forget about. Theta can be pi. And then theta can also be from 5 pi over 3 to 2 pi, but we wouldn't include 2 pi because there's not an actual solution value or a function value where f of x would be 0 kind of thing here. So we wouldn't include 2 pi there. All right, so let's look at the Desmos graph for this one. So here we go. So we can see at 0, it's up here and it's positive, and then it's negative, then it stays negative, then it stays up here positive to 2 pi, which is going to take us to right here. Okay, so did we do that? Did we say positive and then negative, and we stayed negative, and then we were positive at the end? So you can see our analysis on our plus minus number line matches the function values, the y values. The y values from 0 to pi over 3 are all positive. The y values from pi over 3 to 2 pi are all negative. The y values from pi to 5 pi over 3 are also negative. And then the values from pi over 3 to 2 pi up here are positive. And so we, even though these two sections were negative, that one point in the middle is still included as part of our solution set. All right, that wraps up the second part of 3.10, and that's the inequality side of things. So be sure that you are practicing. I went and kind of worked out the math here. This is a lot of things to think about, but I wanted you to be able to see that, yeah, it is doable if you know to pick good numbers. So anytime I'm testing with trig function values, if I can use quadrantal angles or pi over 4, that's what I'm going to use because those are going to be the easiest to calculate with and possibly even be able to do the mental math with. So that wraps up 310. Thanks so much, guys. See you next time. Bye.